So to finish up 7.5, we're going to take a look at two types of word problems, and they are these mixture and work problems. Now, if you saw the end of 7.5 the other day, then you're going to take a look at this work problem and already kind of know what's going on. But here we go. Let's do it again. We have in this question, it says you can complete the yard work at your friend's home in 5 hours. Working together, you and your friend can complete the yard work in 3 hours. So the goal here is, you work by yourself, then it takes 5 hours. You work together with a friend, hopefully it'll get done faster because your friend hopefully is good help. But maybe they're not that good and they're not going to like double or or decrease the time in half right here. So let's see what happens. And it says the question is, how long would it take your friend to complete the yard work when working alone? Now, you'll see right here that the in big ideas they have a table, and I'm not a fan of the table all that much, but there are some parts of it that we're going to use to help us get to our answer here. Okay, and so let's go ahead right here. You can see that I already put up three different words. I put you plus friend equals together. Okay, you plus friend equals together. Whenever we do these work problems, it's usually you have yourself, you have another person helping you, and then hopefully when you work together, it'll actually be less instead of more. So now the question here is, well, how much less, or well, how long does it take your friend if you were to work alone instead of work with you? So as you take a look at the table right here, it shows that they put 1 yard over 5 hours. And that part, I do like. That's how we're going to put this together. I put or one job, okay, over however many hours it takes. So for you, since it takes, you can complete the yard work at your friend's home in 5 hours, we're going to go ahead and put that right here as 1 over 5. Now, for your friend, we don't know how long it takes. So what I'm going to do right here for friend is say, all right, it's still 1 yard, the same yard, and I'm going to put 1 over t for time, the unknown time. To put it all together right here, for together, we do know that it says you and your friend can complete the yard work in 3 hours. So what I'm going to put right there is 1 yard work or job over 3. And so now we came up with this, we came up with our equation right here, our rational equation, and let's go ahead and solve for t. So in order to do that, we've got to figure out, well, what is our LCD? Okay, so we have 5, t, and 3 in our denominator, right? So right here, the LCD, or lowest common multiple, for 5 and 3 is 15, and then we have that t there, so our LCD is 15t. And so we're going to go ahead and multiply everything by 15t right here, or each and every term. So 15t times 1 over 5, the 5 and the 15 reduce, and I'm left with just 3t. 15t times 1 over t, the t's will cancel out, and then it's going to be plus 15. And then finally right here, we have 15t. That'll reduce with the 3, and we'll be left with 5t. All right, so let's go ahead and get t by itself. I'll subtract 3t to both sides, and I've got 15 is equal to 2t. And t is equal to 12 over 2. All right, simply put, if we put that in hours, that is 7.5 hours, or specifically 7 hours and 30 minutes, because half of an hour is 30, or half of 60. And so depending on the question and what they're asking you, you might be able to put 7.5 hours, or 7 hours and 30 minutes might be required. Okay, so you have a work question. And sometimes the work question will ask you, you work this amount of hours, your friend takes this amount of time, and how long does it take for you guys to work together? So the together part would be like 1 over t. All depends on the problem and how they put things together, okay, or what they're asking you for. All right, let's go ahead and go to the next problem. The next type of question we will look at are these classic mixture problems. And these mixture problems right here, these used to be Algebra 1 questions. There are classic Algebra 1 questions that were always on the state test, at least in California. Sometimes they still are. But you know what? It got pushed over to Algebra 2, meaning it could still show up on that state test. So I would go ahead and make sure you write things down, as these are good examples, and you're going to see stuff like this in your homework. The problem says an alloy formed by mixing tau or more metals. Let me go ahead and fix that. It should be 2. So there we go. It now says 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. So if you never knew what sterling silver is, there you go. Why is sterling silver cheaper? Because it's not it's not fully silver. Okay, so that's why you go to a store and you'll find something that has sterling silver, and it's a little bit cheaper. And you know, it doesn't react or behave the same way as silver itself, or full silver, real silver. And it says you have 15 ounces of 800 grade silver, which is 80% silver, and 20% copper by weight. How much pure silver should you mix with 800 grade silver to make sterling silver? Okay, so what they're saying is, like, you've got this 800 grade silver, and it's only 80%. Okay, only 80% of this 15 ounces of silver. Well, I want to get it to become sterling silver. So in order for that to happen, it's like chemistry. You're going to be adding real silver to it, and then that'll increase the amount of silver percentage in that to get it to sterling silver of 92.5%. Okay, or to change that alloy. So here's how I like to set things up. You'll see things differently in the book, and how they set up the equation. But I find, like, look, once you organize the information, you're able to get to the answer all the time without having to guess. Is this number supposed to go here, or this number supposed to go there in the equation, when it's not really known sometimes. But there's a lot of numbers that are thrown around here. Okay? The important numbers that I care about, I have up at the first row. I care about the amount, the percent, and the total. And then in the first column, we talk about the different mixtures. There's mixture 1, mixture 2, and a combination. Okay? So we're going to fill in the blanks and talk about what each of it is. Now, when we talk about amount, that's like the amount of mass, or in this instance, the ounces of each silver right here. Okay, or sterling silver, or the composite right there, the 800 grade silver. So let's go ahead. I'll start off and put right here for mixture 1. Let's go ahead and put 800 grade silver. And my dog Scotty right now seems to not be happy about being here and is making some of those funny noises. It is not coming from me. All right. My little man right here seems to be disappointed or not happy about being here. Hey, go say hi to the camera. Okay. Go say hi. You're being a little bossy today, huh? Say hi. Right over there. Okay. Well, I guess he's being shy. So let's go put you back on your seat. And let's continue on. So when I talk about the amount of 800 grade silver, don't get confused thinking that 800 is a number that I care about. That's really important. It's more of the name of the silver here. But the amount, and I'll go ahead and highlight that, what's important is that 15 ounces. And so I'm going to go ahead and put 15 right here for the amount. The percentage, that's important. Well, what do I care about in this, in our mixture here? I care about silver, and that's 80%. So right here for 800 grade silver. I'm not going to put 80. I'm going to change that to a percent and put that as 0.8. So the idea here is this. If I take the amount and I multiply it by the percent, that will equal our total. So let's go ahead, you take your calculator, 15 times 0.8, and that right there equals 12. Let's take a look at what's our second mixture, okay? What is the second thing that we're looking at here? And that happens to be pure silver, okay? Those are the two things that we're mixing. 800 grade and then this pure silver. So I'm going to go ahead and put right here for mixture 2, pure silver. And so what is the amount of pure silver? Well, we don't know. Pure silver, we're going to go ahead and put X. Now, how much silver is in pure silver? If it's pure, it's 100%. So what I'm going to go ahead and do right here is change that to 1. Right? 100% would be the same thing as 1. It's a whole. And then finally, we have the last part, or actually, let's go ahead, we'll multiply the two together, and we'll end up with 1x, or just x by itself. So now we go to the last piece, our combination. The combination of the two, what does it comprise of? We're trying to get at sterling silver, and I just went ahead and highlighted that right now. So the combination of 800 grade plus pure silver is for us to get our sterling silver. Okay? And so what are we trying to do right here? Our amount. Well, how much sterling silver do we have? I don't know. But what I do know is this. If I take the amount of 800 grade silver, which is 15, and I add the amount of pure silver, which is X, that will get me this amount of sterling silver that I need. The percent, okay? Well, sterling silver is an actual percentage, or where the item has a certain percent of silver in there. And that certain percent is 92.5%. So right here, I want to go ahead and change that to 0.925. And so when I multiply the two together, on this one, you're going to have to do a little bit of distributing. And so we got ourselves 0.925 times 15. That's going to get us 14.2, or sorry, let's try that again. Looks like that will be 13.875, and then 0.925 times x will be plus 0.925x. And so what I now do at the very end to figure out what our answer, or what we need right here, is we're going to take mixture 1 plus mixture 2 and set it equal to the combination, or what it would be sterling silver right here. So let's go ahead and I highlighted that last column. And so what I'm going to do is take 12 plus x and set that equal 13.875 plus 0.925x. And so right here, let's go ahead and get x by itself. I'll subtract 0.925 x to both sides, and we're going to get ourselves, don't forget, in front of this x is a 1. So we got ourselves Let me go ahead and just put that there. And so that'll get us 0.075x. And then we'll subtract 12 to both sides. This right here should be pretty straightforward. And then you end up with 1.875. So at the end, right here, okay, so there's our numbers. And then let's go ahead and divide both sides by 0.075. And x is now equal to 25. So what does this 25 mean? That's what x is. And what's x? It's the amount of pure silver necessary. All right, so how much pure silver is necessary? 25 grams. And there you go. There's your answer. All right, think about it. If you want to dilute something, like let's say you have coffee and you want to dilute it because it's too strong, you would add water in it, right? But if let's say your coffee was too weak and you want to make it stronger, you would hopefully add more stronger coffee into it to get the coffee to be bolder. Okay, so that's the same idea right here. We have silver, or we have this 800 grade silver. We want it to become sterling silver, so you had to add real silver to it to bring the percentage of silver in this 800 grade silver up to sterling silver levels of 0.9 or 92.5%. Okay? Now that we have that, let's try it one more time. We have our mixture problem number 2. Starts off, white gold is an alloy composed of 75% gold and 25% palladium by weight. You have 12 ounces of an alloy that is 60% gold and 40% palladium. How much pure gold should you mix with this alloy to make white gold? How much pure golf? I wish I could be golfing right now, but that's not the case. Let me go ahead and change that. All right, so now I have that fixed right here. How much pure gold should you mix with this alloy to make white gold? So remember, we have two mixtures and what we're trying to come up with. Okay, so what are we trying to get? First off, we're talking about white gold, but then you have 12 ounces of an alloy that is 60% gold and 12% palladium. So I'm going to put right here for mixture 1, we have this alloy. Okay, and in this alloy, we have 12 ounces. Boom, boom. And the percent right there of this gold happens to be 60%, so we'll take that and change it to 0.60 or 0.6. Remember, to go from percent to decimal, decimal to percent. You should hopefully know that. I'll put it right here. Decimal to percent, percent to decimal. Remember, you move your decimal points 2 spots to the left or to the right, depending on where we're going. Since we're going from a percent to decimal, I move that decimal point 2 spots to the right and end it with 0.6. And I've got this little diagram for you here to maybe help you remember that. Let's go ahead. If I take 12 times 0.6, that becomes 7.2. So next up, we're trying to get white gold, okay? So that will be our combination, white gold. So I'll put that down right there. So then what's mixture 2? Well, mixture 2 is this pure gold. We're going to add pure gold to get it to go from, 60% gold and get it up to 75%. So pure gold, we don't know how much the percent of gold in pure gold, hopefully it makes sense. It's 100%, so we'll put 1 right there. So I got 1 times x, and I got 1x, or just x right here for the total. And then let's think about the bottom, our white gold. Okay, I don't know how much white gold we need, but if I put it together, 12 plus x is the amount of white gold that we will have in the end. Okay, 12 grams of alloy plus however much pure gold we're going to add. For our percent right here, I've got 0.6 times 1. Okay, and now the thing right here is what is the percent of gold in white gold? It's 0.75, so I'll go ahead and circle that up there for you and put 0.75 so you know where it comes from. And then for our total, it's going to be, we go ahead and take 0.75 and multiply that by 12 plus x. So I go ahead and do that. 12 times 0.75 is 9. And then 0.75 times x is 0.75x. All right. And there you go. So the last thing is we take this last column, we'll take the totals, and we'll combine it together to get our answer. Mixture 1, or alloy, plus the pure gold, which is unknown, that's going to be equal to the combination of 9 plus 0.75x. We'll go ahead and solve for x. I'll subtract 0.75 to both sides, or 0.75x to both sides. And so right here, I've got 7.2 plus 0.25x is equal to 9. And then let's go ahead and subtract 7.2 to both sides. And then 9 minus 7.2 is 1.8. So at the end, we divide both sides by 0.25. And x is now equal to 7.2. And it's 7.2 ounces right here. That is the amount of pure gold you need to mix into our combination, or mixed with alloy, to get ourselves white gold. All right. So hopefully you can visualize what's going on. If not, ask me, and I'll try to show you with some diagrams and explaining all of this right here together. So that wraps up 7.5. We're looking at the work and mixture problems to go along with the section, which happens to be all about solving rational equations. All right, and there you go. Hopefully now we finished up 7.5. And Scotty bids you farewell. Scotty, look at the camera. Look over there. No, you don't want to? You're very interested in all the other stuff here, huh? All right. Well, I'll see you guys later, and have yourselves a good one.